Hey there guys, welcome to the video. My name is Pushpinder Gill. In this video, we are going to do the regression, right? So we're going to be starting with regression here, and this is the first video on regression. So we'll actually be touching the basics of regression. Well, we'll actually be completing it in some sense. However, we'll be just doing the basic part of regression here. So if you have no idea about regression, this is the video to watch. And even if you have a little bit idea of regression, this is the video to watch, because this is going to be completely logical. I'm not going to throw any formula at you. I'm actually going to explain it to you. How do we perform regression analysis? Now let's go ahead and get started, guys. Now again, what is the purpose of regression? Why do we use regression? Well, first of all, I'm actually going to introduce you to a simple problem. The problem is that we want to find out the relationship between two variables. Well, the relationship between two variables. Let's suppose if I have two variables, variable X and variable Y. X and Y could be anything. It could be the number of sales and it could be the number of months, right? Or it could be the number of years, or it could be the number of sales. So the variables can be any variable, but we want to find out the relationship between those variables. Now you would think, don't we have the coefficient of correlation for that to actually find out the relationship? Well, it's a little different and it's a little advanced than coefficient of correlation here, because in correlation we only know in correlation, we only know the kind of relationship that they have in terms of positive and negative, whether things are positively correlated or whether things are negatively correlated. We cannot model with correlation. We cannot model two variables and actually find the equation of two variables, right? So this is something that we cannot do in correlation, and this is where the need arises for something more sophisticated, and that is what we have is regression. So what does regression do? The regression actually tells you the relationship between two variables and kind of gives you a kind of an equation between two variables. So if let's suppose I get the equation y is equal to 2x plus 3, and y could be the number of sales and x could be the number of inquiries. So you can clearly say that the number of inquiries is related to the number of sales in this way, right? So that's what it is, right? So just a simple example that I've used, right? So inquiry, right? All right, so I hope you understood this part here, guys. Let's move forward to the next one. So that was the purpose of regression. So in this video we are just going to be doing linear regression. Now what do you mean by linear regression? Something that is so we actually try to find the relationship between two variables, variable X and variable Y. Now linear regression just involves a linear relationship between variable X and variable Y. So all we do is we just try to find out the linear relationship between X and Y. And what is linear? Linear is something that if you watch the linear videos, linear is something which is a straight line, right? So what we do is you try to find the straight line relationship between two variables. So this is variable Y and this is variable X. Now if you watch the linear equation videos which we have, you would know that the linear equation is of this format, that y is equal to mx plus c, right? And what is this m over here? M is the gradient of the line, or you can also call it the slope of the line, right? So it's also the gradient of the line, or also called as slope of the line. It kind of tells you how is the line oriented, or it kind of tells you what is the change in y divided by the change in x, or y2 minus y1 over x2 minus x1. I hope you remember all this from the linear equation if you studied it somewhere else, or even if you watched the videos here with us, right? So that is what the slope is. Another thing is this c. C is nothing but which is the y-intercept. Now what is y-intercept? Y-intercept is the value of y when x is equal to 0. This right here is the y-intercept. That is the value of y when x is 0. So this distance will be c. So based on these two things, the gradient and the y-intercept, we actually get this equation that y is equal to mx plus c. Just to actually get you warmed up a little, what I've done is I've actually picked up a question here just to get you warmed up. So we have this line y is equal to 2x plus 3. If y is equal to 2x plus 3, then the question is asking write down the gradient. So if we compare it to y is equal to mx plus c, we would be able to see that m is actually equal to 2. So the gradient of this line is actually equal to 2, and the slope of this line is actually equal to, the y-intercept of this line is actually equal to 3. Now if I were to sketch this line, the line will actually pass from this point, that is 3 points above the x-axis, because the y-intercept is 3, right? And since the slope is 2, that means if x rises, y will also rise. That means this is going to be the gradient. Fine, this is going to be our line. Now how does regression helps us in there? So if you're able to get this bit of line, we'll be able to extend this line forward and extend this line backward to actually get the future or the past relationship, right? So this is something that we can do with regression. This is where regression helps us. Fine. So moving forward, so what do we have when we do regression? So let's suppose if I say I have two values, I have value x and I have value y. Fine, and I say let's suppose this is the value of x, 1 2 3 4 5, and let's say these are the y values, let's say 4, let's say 7, and let's say 10, and let's say 12, and let's say 10 again, right? So this is x and this is y, right? So we have these two variables. Now if I plot these two variables on my axis here, so what I'm gonna have the y-axis, I'm gonna have the x-axis. I'm gonna plot 1 2 3 4 5. That is 1 2 3 4 5, and let's say I want to plot from 4 to 10. So I'm gonna start with 4 6 8, so let's say 2 is here, 2 4 6 8 10 and 12. So if I just plot this point, so this is 1 comma 4 1 comma 4, this is 1 comma 4 2 comma 7, so 2 comma 7 comes here, right? And 3 comma 10 3 comma 10 comes here, and then I have 4 comma 12 4 comma 12 comes about right here, and then I have 5 comma 10, so 5 comma 10 comes about here. Now what do I have to do? I have to find the relationship between x and y. So if I want to find out the relationship between x and y, I need to find a line which best fits x and y, which kind of gives me the best possible relationship between x and y. Well, I can draw unlimited lines here, isn't it? So let's suppose I draw this line right here like this. Let's suppose this is the line. Now that means if I've drawn this line has certain errors, isn't it? This line gives me certain errors. And what are these errors? This error is, so let's suppose the question here says that, so this line here says that if x is 2, y is gonna be this. This is what this line is saying. If x is 2, y is gonna be this. But in actual terms, y is this. When x is 2, y is gonna be this according to the line. But in actual terms, y is this. That means this distance right here, it's an error, isn't it? So how do I reduce this error? To reduce this error, what can I do is I can actually make the line a little bit like this. So that means this is another error, but this error is smaller than the previous error. So that means I can say that this line, suppose this is line 2 and this is line 1. I can say that line 2 is better fit than line 1, isn't it? So line 2 is better fit than line 1. Similarly, I would say that line 3 is a better fit than line 2. I can say that line 4 is a better fit with line 3. And you know what? There can be unlimited number of lines, when there would be unlimited number of possibilities of better. However, there is only one line which is best, right? There is only one line which will fit best for these possible, for these points over here, right? So our job is to actually find that best possible line using various mathematical relationships that we have actually found till now. Fine. So let's actually move forward. So my objective over here of this slide was to tell you that there can be unlimited number of regression lines, but there is only one line which actually fits best. in the circumstances given the data that we have, right? So this is what it is. So I hope you understood this here, guys. Let's actually move forward, right? I'm just gonna skip that. Let's actually move forward and talk about one thing before we actually go ahead and derive the relationship for regression analysis. That is the difference between independent and dependent variables. Now, what are dependent variables and what are independent variables? So let's say, for example, I say that you have this y-axis and you have this x-axis. Now, independent variables are the variables which are completely independent, as the name suggests, and the dependent variables actually depend on the independent variables. Their value is derived from these independent variables, and whenever you do a regression analysis, x always has the independent variables while y will always have dependent variables. Right? So x will always have independent variables and y is always going to have dependent variables, right? And dependent variables values are kind of dependent on the independent variables. So independent variables comes first. So they come first and then dependent variables come. Let me just give you a simple example, right? So let's suppose a company wants to predict sales of a new album by a pop group. They know the yearly sales of a number of existing albums by the same group. So they have the yearly sales. So that's one variable. And they have the number of stores that stock each album. So another variable is the number of stores that stock each album. Now, tell me, which came first? Did the number of stores which stock the album came first, or did the yearly sales come first? Obviously, the number of stores which stock the albums came first. That means this over here is an independent variable and this over here is a dependent variable because this comes first, so this is kind of dependent on this. So if I do a regression analysis on this, obviously the independent variable will come here and the dependent variable will come here. Fine. So I hope that's fine, guys. I hope you understood this point here. I'm going to move on to the next part. Okay, so let's go ahead and find the line of best fit. In order to do that, what I'm going to do is I'm actually going to start with a sample data, right? So let's say this is our sample data right here. We have our x values and we have our y values, right? So these are the x values and these are the y values. So what I've done is I've actually taken the liberty to go ahead and plot these values because you don't want to waste time in doing that. Now, what do I want to do? I want to find the line which best fits this diagram right here, right? So, what should be my purpose? How should I conduct this experiment, right? So the line could be anything, so the line could be like, let's say this line, right? So what do I want to do? What I'm trying to objectify here, right? So what I'm trying to do, well, if I say this is the line, let's suppose this is the line which passes through these points, this distance from here is actually going to be my error, right? And this distance from here to here is actually going to be my error also. Now let's say, for example, if I say this is my line, let's suppose if I say that this is my line right here, this is the line which best fits this criteria. Well, okay, so this distance is going to be my error, this distance is going to be my error, this is going to be my error, this is going to be my error, and this is going to be my error. So let's say this is error 1, error 2, error 3, error 4, and error 5. So what is going to be the sum of all the errors? The sum of all the errors is going to be error 1, error 2, plus error 3, error 4, and error 5. Now my job is to minimize these errors. Right? So what's my job? My job is to minimize the sum of errors, right? So that's my first job. Okay, now let's understand if that is if that is an objective. Does that make sense? Well, in some way it makes sense. However, there's one little problem in this experiment. The problem is that E1 is going to have a positive sign because this is something which is giving me more than usual, E2 is also giving me more than usual, but E4 is going to carry a negative sign because this is less than usual. Now what's going to happen? E1 and E4 is going to subsidize E1. So let's suppose this error is positive 2 and let's suppose this error is negative 4. And if you add 2 and 4, you actually get a negative 2. So that means what's happening here? The positive errors are being subsidized by the negative errors, right? So the positive errors are being subsidized by negative errors, and I'm actually taking negative errors differently as compared to positive errors. There I'm considering them different. However, both are same. An error of 2 on this side, an error of 2 on this side should be the same. That means then what should I do? To actually account for that small little problem, instead of finding the sum of errors, I'm actually going to find the sum of the square of each error term. Because when I square a term, the sign that will have will automatically become positive. And then what will happen? Then I would be considering the negative sign and positive sign equally. So what do? I actually find the squares of the sums, right? So I square each term up and then find the sum. Because let's say, for example, this is 5, right? So let's suppose this point is 5, okay? This point is 6 and this point is let's say 4. Then this is negative 1 and this is positive 1, right? If I find positive 1 and negative 1, that tells me there is no error. But when I say positive 1 square and negative 1 square, that actually gives me 2. Isn't it? So that actually tells me that there is an error. So there is a problem if I add the individual errors, which is why I will square them up and then I'll add them. So my objective here becomes to actually my objective here is to minimize the summation of error square. So that's my objective, and I want to make it 0, right? Possibly that's what my objective is. I want to make it 0. Well, it's not going to be 0 because if it were 0, then we'll have a straight line. But what our job is? Our job is to minimize this as much as possible. Now, how do we minimize this here? Well, what I've done is I've actually made a series of 5 videos which is actually of graduate level, right? In one of the videos, sorry, there are 5 videos on it, which actually shows you the proof of how do I minimize this. I'm not going to do that right here because this is the basics video. Probably you should not be watching that, right? So let's actually fast forward it and let me show you how do we perform regression analysis. Now, we wanted to minimize the errors. Now, one thing over here is, what is the x bar? What is the mean value of x? If I calculate mean of this, that is this plus this plus this plus this plus this divided by 5, well, the mean is going to be 3. And what is the mean of this? The mean of y values is going to be equal to 3 plus 8 plus 14 plus 11 plus 22, and that divided by 1, 2, 3, 4, 5, and that divided by 5. So the mean of this is going to be 11.6. So the mean of x is 3 and the mean of y is 11.6. Now another thing, a regression line. So what are going to be the properties of those regression line? A regression line is definitely gonna pass through. It's gonna pass through the point x bar and the point y bar, because this is something which is the mean of both the values. So that means our regression line is definitely gonna pass through this line over here, this line over here, and this line over here, that is y bar. What is the y bar? 11.6. So let's say 11.6 is somewhere right here, and this line here. That means our regression line is definitely gonna pass through this point, which is x bar, that is 3, and y bar, which is 11.6. So our line definitely passes through this point. So that means we have a point through which our line is passing, right? Now, another thing is that we have to decide the slope of the line, right? So what do we have to do? We have to actually decide the slope of the line. Now, first of all, the first important point is, how do we decide the sign of the slope? How do we decide whether the slope is going to be positive or the slope is going to be negative? Now, the sign of the slope is actually will be decided by the covariance of x and y. What is the covariance of x and y? Covariance of x and y is actually equal to s of of xy divided by the number of terms. That is actually equal to summation of x minus x bar into y minus y bar divided by the number of terms. Now, what is the covariance of x and y? There is a special video on covariance of x and y, guys. Now, covariance of x and y is actually going to tell us what happens if x increases. So if covariance is positive, that means if x is increasing, y is also increasing. If covariance is negative, that means if x is increasing, y is decreasing. So that is pretty much the important point for slope. We have to find out, is the slope positive or is the slope negative? That means the covariance is something which decides whether the slope is going to be positive or the slope is going to be negative, right? So that's one important thing. Another important thing is we have to also find out the magnitude of the slope. So the magnitude of the slope will actually be given as covariance of x and y divided by the variance of x. So this is how we're gonna be finding the slope. Well, don't think that is too difficult. I'm gonna make it very easy in the next few minutes. The slope value is equal to the covariance of x and y divided by the variance of x. Now, what is the meaning of that? Now, variance of x is always going to be positive because variance is always positive. Now, this can either be positive or this can either be negative depending on the relationship between x and y. And the magnitude of this is going to give us the magnitude of the slope. Now, if covariance of x and y and the variance of x are same, then the slope is going to be 1. Simple as that, right? And it actually makes sense because if the slope is 1, that means the rate of change of y and the rate of change of x is the same. That means a variance of x is actually equal to covariance of x and y, isn't it? That means the rate of change of x is equal to the rate of change of y, right? For that means the slope is actually equal to, the slope is equal to 1. So what is covariance of x and y and what is variance of x in terms of formula? Well, covariance, the slope is actually going to turn out to be equal to summation of x minus x bar into y minus y bar divided by the number of terms. That's covariance of x. And what is the covariance of x and y? And what is the variance of x? Variance of x is going to be summation of x minus x bar whole square divided by the number of terms. Now, these number of terms and these number of terms cancel out each other. That means the slope for regression is actually going to be equal to summation of x minus x bar into y minus y bar divided by summation of x minus x bar whole square. So this is the slope of the line, right? It actually tells you how x, so this, if I think logically, that is actually equal to, slope is actually equal to how are x and y changing together? How are x and y changing together? Divided by how is just x changing by itself. So how is x changing by itself? So if x and y, that's actually the meaning of variance is. Variance tells how x is changing, how x is far away from the mean, and this over here is how x and y are changing with respect to each other. When you find the ratio of that, you actually get the slope of the regression line, right? So if they both are equal, then the slope is 1. Isn't it? If they both are completely opposite, then the slope is -1. And the variations of these actually gives you the actual value of slope. So coming back to this again, if I come back to this again, first important point is that the line will pass through x bar and y bar. Second important point is that the slope of the line is going to be equal to covariance of x and y divided by the variance of x. There is a special video on the mathematical video on the derivation of this. So that is equal to summation of x minus x bar into y minus y bar divided by summation of x minus x bar whole square. Now, how do we find the y-intercept? How do we find the y-intercept? That is the value of c. Now, you know that the line passes through this point. That is, the line passes through x bar comma y bar. Fine. And this is the point that the line passes through. And the equation of the line is y is equal to mx plus c. So that means y bar is equal to, if I substitute these points here, y bar is equal to mx bar plus c. That means c is going to be equal to y bar minus mx bar. And what is m equal to? M is equal to the slope, which you're going to find using this. So this is how you will find the value of the intercept, that is y bar minus mx bar, because you already know that the line actually passes through this point. Fine. So I'm going to revise what I just said. First important thing that the line will pass through x bar comma y bar. So that's the first important thing. The line passes through this point. Second important thing is the slope is summation of x minus x bar into y minus y bar divided by summation of x minus x bar whole square, which is actually equal to s of xy divided by s of xx. So this is what it is equal to. If you see the previous video, we actually got two different formulas by which you can calculate s of xy and two different formulas by which you can actually calculate s of xy. Right? So you can actually watch that video. And the third thing over here is that this c is going to be equal to y bar minus m into x bar. So this is how you're going to get the value of c. So I hope you're understanding here, guys. I hope you're able to understand my point. So what I'm going to do is I'm actually going to do an actual question on this, right? So let's do this question and let me show you how we perform regression analysis and how do we get the relationship between two variables. So what do we have here? We have our x values, that is 20, 40, 60, 80, and 100. We have our y values, that is 48, 55.1, 56.3, 61.2 and 68, right? So these are our x values and these are our y values, right? Now we have to perform a regression analysis. We have to find the relationship between the mass and between the length, right? So mass is something which is independent and y is something which is dependent, as they've already told. Like, this is the x value and this is the y value. Now how do we find first of all, we have to find the value of x bar and we have to find the value of y bar, right? So what is going to be x bar? X bar is going to be equal to, x bar is actually going to be equal to summation of x divided by the number of terms, right? So what is the summation of x? So if I add 20, 40, 60, 80 and 100, so if I add 20, 40, 60, 80 and 100, and if I divide this by the number of terms 1, 2, 3, 4, 5, so the sum is 300. If I divide this by 5, I'll actually get 60. Another quick way is, since you can see they're equally spaced, there's a difference of 20 in each term, the middle number is going to be the average, so the average is 60. Well, let's just, that's a story for a different game altogether. So x bar is 60. Let's calculate the value of y bar. Y bar is going to be 48 plus 55.1 plus 56.3 plus 61.2 plus 68. So that's 288.6, right? So this is 288.6. We're going to divide that by 5 also to actually get the value of y bar. So y bar turns out to be 57.72. All right. Now, so x bar is this and y bar is this. So how do we get the value of slope? Slope is equal to summation of x minus x bar and y minus y bar, x minus x bar into y minus y bar divided by summation of x minus x bar whole square. So what I'm going to do is I'm actually going to find out the value of x minus x bar and I'm going to find the value of y minus y bar. So what I'm going to do is I'm going to subtract this 20 from 60. So 20 minus 60 is minus 40. 40 minus 60 is minus 20, 60 minus 60 is 0, 80 minus 60 is 20, 100 minus 60 is 40. Fine. So that's x minus x bar for you guys. Now let's find y minus y bar. So if I have to find y minus y bar, so first of all I'll do the y bar is 57.72. If I subtract 48 from it, I'm using my calculator, don't think I'm some kind of a genius here, right? So that's there, and this minus 55.1 is actually equal to negative 2.62. Just a sec, guys. Minus 56.3 is actually equal to 1.42. The average is 57, so that's negative, right? And then I have 61.2 minus 57.72, so that's equal to 3.48, and 57.72 and subtracting 68 from it, I get 10.28. So that's x minus x bar for you, and that's y minus y bar for you guys. Okay, so what is equal to, now I have to find x minus x bar into y minus y bar. So I'll actually multiply x minus x bar and y minus y bar. So what I'm going to do is I'm going to multiply this with this. So I'm going to multiply 9.72 with 40. So I'm going to get 388.8. Then I'm going to multiply 2.62 with 20, right? That is 52.4. I'm going to multiply 1.42 with 0, so that's 0, right? Then I'm going to multiply 3.48 with 20. So, sorry, 3.48 with 20. So that's going to be 69.6. And I'm going to multiply 40 with 10.28. We're almost done here. So that's 411.2. Now, what do I have to do? Another thing that is left is x minus x bar square. So what do I have to do is I have to square it up. Just since I'm lacking a space here, I'm actually going to write here. 40 square is 1600. This is 400. This is 0. This is 400. This is 1600. There you go, guys. Now, let's find the summation of x minus x bar. Add them up. 1600 plus 400, 2000. 1600 plus 400, 2000. 2000 plus 2000 is 4000. That's fine. Let's add this up here. That is 388.8 plus 52.4 plus 69.6. Usually I use my Excel for that since I'm making a video here. So it's actually going to be like this. Okay, so the value of m is going to be summation of x minus x bar into y minus y bar, which is 922, divided by summation of x minus x bar whole square, that is 4000, right? So my answer here, my answer for slope is going to be 0.32305. So my slope is 0.2305, and the value of c is going to be y bar minus mx bar. So y bar is actually equal to 57.72 minus m. My m is 0.2305 into x bar. So that's multiplied by x bar. What is x bar here? 60. So the value of c is going to be equal to 0.2305 into 60. And then I subtract 57.2 from it. I get 43.37. So the equation, the regression equation is y is equal to m, which is this, x plus c. It's a small change here. This is actually 43.89. My bad. This is 43.89. Fine. So this over here is my answer. So I hope you understood what I did here, guys. So calculation is kind of secondary. The primary thing is I had the value of x, I had the value of y. I found the value of x minus x bar. I found the value of y minus y bar. I multiplied x minus x bar into y minus y bar. I squared the x minus x bar square. This is this summation, this is this summation, divided them up, got the value of m, and used this formula to get the value of c. So I hope you're understanding my point here, guys. I hope you're able to understand the regression. So I'll just summarize all the things here. So if you have a regression analysis of y is equal to mx plus c, m is equal to summation of x, basically s of xy over s of xx, and c is equal to y bar minus m x bar. Fine. So I hope you understood this point here, guys. Thank you very much for watching this video. I hope you understood what I was trying to say here. There's going to be more videos on regression analysis for sure. We're also going to be doing quadratic regression and all other types of regressions. So thank you very much for watching this. I'll see you in the next one.